Okay, so what we have is we have this piece of cardboard. A box is made from this piece of cardboard that is 16 by 12 inches. And the way we're going to make this box is we're going to cut little corners out of this. So a little corner from the edge. So after we cut those out, it's going to kind of look like this. Right? When you fold those up, you end up creating a box. So that's the idea here. So notice after the question is how big, where are we here? So find the dimensions that will maximize the volume, all right? So we're going to cut, the question is how big of a corner do we cut out? So that when we fold it up, we can fit the most stuff inside the box. So let's call the distance, the size of the square that we're cutting out x by x, because we don't really know how big that's supposed to be. Once we cut that out, well, the distance, the length of the little flap that we're going to fold up is going to be 16 minus 2x. Yeah. So this is 16. So after we fold that up, this is 16 minus 2x. This distance is 12, take away 2x, leaves us with that. And after we fold it up, well, the height, this distance here is x, yeah? So when we fold it up, the height of the box is going to be x. So our volume of the box, after we cut it, the squares out and fold it up, the volume is going to be length times width times height. The height is x. So we get 16 minus 2x times 12 minus 2x times x. This is, we're trying to maximize the volume. That's why we need an equation for the volume. This is an equation in one variable, so now all we got to do is take the derivative and find out which x values, take the derivative, set it to 0. So let me first start by factoring out some constants here. I can factor out a 2 here, and I can factor out a 2 here, and the 2 times 2 gives us 4. So that gives us 8 minus x, and this is 6 minus x. So now our volume is 4 times 48 minus 8x minus 6x is minus 14x, and negative x times negative x is positive x squared. Now distributing the x, we get 4, and I'm going to rearrange this, write it in descending order. So we have x cubed minus 14x squared plus 48x. Okay, so now I'm going to erase this. And now what we want to do is take the derivative. Now when we take the derivative, all we got to really do is take the derivative of this quantity, because we don't need to worry about the 4, because the product rule, the first times the derivative of the second, while the second times the derivative of the first, well, that's going to be 0. So all we've got to do is take the derivative of this. So the derivative is 4 times 3x squared minus 28x plus 48. And we want to know, when is this 0? Well, if we divide both sides by 4, what we're really solving is 3x squared minus 28x plus 48. We want to know, when is that 0? All right, so let's see. Does this easily factor? I do not believe it does, so let's use the quadratic formula. So x is equal to the opposite of negative 28, 28 plus or minus the square root of 28 squared, negative 28 squared, but it's going to be positive, minus 4 times 3 times 48, all over 2 times 3 is 6. Now just to save a little time here. When we plug this in and take this square root just to get a decimal equivalent and round it to 1 decimal place, we get 28 plus and minus 14.4 over 6. And our two answers are therefore, I need a bigger board to do this, but I'm a little limited. So now our two answers are 28 plus 14.4 over 6. And the other answer is 28 minus 14.4 over 6. When you plug in the first one into your calculator, you get 7.1, and here you get 2.3. Now, here again, just think about it. 7.1 can't be the answer, because remember, what did we originally, this is 12 by 16. If this distance is 7.1, well, 7.1 and 7.1 is 14.2, and we don't even have that much distance because it's only 12 inches. So this one, just thinking about it, can be thrown away, and the answer has to be this. So the size of the little corner that you want to cut out in each corner, the size is 2.3 by 2.3, at least rounded to 1 decimal.